Okay, using your calculator, I want you to find the solutions to this quadratic equation. I'm going to pause it and give you some time to do that. So on your graph, you should have noticed the looks here, and then you can go to the table. And it looks like it has one solution. It looks like the solution is at -1, 0. And you go back to the graph, and you can see the vertex looks to be around -1, 0. However, there are actually two solutions, so you have to be careful. So you need to zoom in. See for zoom 2. And when you zoom in, you can see that there are two solutions. One of them is at -1, 0, but the other one is going to be smaller than -1, 0, but not quite to -2. And it will not show up in your table because your x, it's going to be a decimal answer. So that's why we have to be careful sometimes that it's not just from the graph. So there are two more ways of finding solutions to quadratic equations other than graph and the table that we've already learned. And those two things are factoring, which we could factor this, which we're going to get into, or using the quadratic formula. We're going to get more into factoring after your STAR test, but quadratic formula is what we're going to concentrate on today. So here is the quadratic formula. Please write this down. You will need to have the formula written down. It will also be on your math chart so you don't have to memorize it. Okay, it looks crazy, but as long as you know how to use ordered operations, it's very easy to use. So in order to use the quadratic formula, first thing you have to do is identify your A, your B, and your C. Okay, let's remember standard form. Your equation has to be in standard form. And A is always in front of x squared, B is always in front of x, and C is always by itself. So I'm going to give you some time. I'm going to push pause. I want you to identify the A, B, and C of that first problem that we just did in our calculators. Okay, you should have gotten 2, 5, and 3 because 2 is in front of x squared, so it's A. 5 is in front of x, so it's B, and 3 is by itself, so it's C. So now we're going to plug in for A, B, and C. So remember when we plug in, you replace the letter you're plugging in with parentheses. So all you have to do is fill that in. So I'm going to rewrite the equation with just parentheses instead of A, B, and C. And I'm going to plug those numbers in. I'm going to use a different color so that we can see that. Okay, so the first one is B is 5, so 5 goes in the first parentheses. 5 goes here. A is 2, C is 3, and A is 2. Okay. So now we have to use our order of operations. So the first thing we're going to do is do everything underneath the square root sign. So this is kind of like the parentheses. So we're going to do this first. You're not going to do square root though. So you're going to type everything in that's under the square root. So please do this along with me. Parentheses included. Oops, that didn't have parentheses. And you should have gotten 1. So when we write it, everything else stays the same. Square root still stays there, but it's 1. Okay, after you have, oops, let me move it down. After you have that, sometimes your answer is going to look just like this as your answer. Oh, that wasn't 4, it was 2 times 2. I jumped a step ahead. Okay, now we have to simplify each portion. So this portion, and this portion. So we do that one step at a time. -1 times 5, remember that's a -1. -1 times 5 is -5. The plus or minus stays there. I look in my calculator and see, you should already know that square root of 1 is square root of 1, but just double check, you look in your calculator and it's 1. So this disappears and it turns into 1. And then 2 times 2 is 4. If it would have been square root of 3 on the other hand, that does not simplify to 1.7. Not like you did in 8th grade where you just estimated. You would leave it as square root of 3. We'll get in more to that with the next example. Okay, so this is your answer, which we can simplify. This needs one of your x's is negative 5 plus 1, and then we divide the answer by 4, and the other x is negative 5 minus 1, so that's what that means. So we're going to do the first one, negative 5 plus 1, and then divide by 4. So you do it step at a time, order of operations. You do negative 5 plus 1 is negative 4, and then divide it by 4. One step. You get negative 1. Okay, the other solution, you do negative 5 minus 1 over 4. So negative 5 minus 1 is negative 6, and then divide that by 4, and you get negative 1.5. So that's your two solutions, negative 1 and negative 1.5. You go back to our graph, and you go to your table, and you see it's exactly at negative 1, 0. Now you can use your graph to estimate that as well, but that gives you the exact answer using the quadratic formula. Negative 1.54 is what I got, but negative 1.5 is the correct, exact. Okay, I'm going to do one more example for the video. I'm going to push pause right now, give you a second to reflect back on the steps that we took. Okay, so after we identified A, B, and C, we plugged them into the plugged it in. Then we simplified this part first, and then we simplified each portion. Since the square root of 1 actually simplified to 1, we can actually break it down into two separate problems. Alright, second example. Alright, so the first thing that we always are going to do is graph it in our calculator to make sure that there is a solution. If there's no solution, then there's no sense using the quadratic formula. And if we can put it in our calculator and get the exact solutions without using all that formula, then that's what we're going to do. So in order to put that in my calculator, remember, it has to be equal to 0. So I need to move that over here by subtracting 1x, and I get negative 3x squared minus 1x plus 6. So when we graph it, we got to make sure that there are solutions. Oh, I still have my calculator zoomed in, so I'm going to push zoom 6. And I can see that there are two solutions, but they are not exactly on a whole number. So there are going to be some decimal answers again. And you go back to your calculator and you can't see where it exactly crosses 0. So we're going to go ahead and use that quadratic formula. So I label your A, your B, and your C. I'm going to rewrite the formula. Okay, so make sure if you don't have that formula still written down from the previous example, you rewrite it. And I'll give you about 30 seconds to identify the A, B, and C. Alright, so A is negative 3, B is negative 1, and C is 6. So we're going to use that to plug into our formula. So I'm going to replace all of the A, B's, and C's with parentheses so we can plug in. Alright, so this is where it gets tricky sometimes, because this is negative 1. A lot of students like to just put 1 there, but it's actually still negative 1. You've got to make sure that if it's negative, you plug it in as negative. Alright, so we got step 1 and 2 done. Now we need to go through and simplify. Okay, we're going to put everything here into our calculator other than square root. So then we're going to rewrite everything else. Negative 1 squared minus 4, and 3, and 6, and you should get 73. Okay, after we have it looking like this, we need to simplify each section. Remember, negative 1 times negative 1 would turn to a positive 1. So that's disappeared. Plus or minus stays the same. Try second square root of 73. Guess what? It's irrational, so we're going to leave it at square root of 73. And then we do 2 times negative 3. Oops. It's negative 6. And guess what? That's my final answer. You don't have to simplify it because square root of 73 doesn't simplify. So if that was the exact answer, that's what you would see on your test choice answer choices. Only if it can simplify, like our first example, because square root of 1 simplified, we're going to get actual number answers. But if the square root or the radical cannot be simplified into a nice number, then it's going to have a square root in its answer.